to Threat Hunting on Android with Trace Control, presented by me, Matt Boddy, the CTO here at Traced. We're going to start off with a very, very short presentation here and then move into some practical threat hunting and how you can do that with our platform, Trace Control. Now, I don't want to take up too much of your time with the presentation because nobody likes death by PowerPoint, and nobody especially likes these huge animations that some people put in, these massive slide transitions that open up like curtains and explode when you go to the next screen with things flying in from the side and all angles. So this here is a quote from NIST, specifically the Computer Security Incident Handling Guide. And what it says is that, and it's very early on in that guide actually, and it says that understanding threats and identifying modern attacks in their early stages is key to preventing subsequent compromises. Now, this is a very, very pertinent quote specifically for Android threat hunting, because I know a lot of incident response teams out there aren't going to have anything in place for threat hunting or incident response on their Android devices. Some people may have an MDM in place or EMM in place in order to lock or wipe that device, but it's very difficult to know unless that device has specifically been raised as being stolen as to when they should do that. And that is what an MTD, a mobile threat defense platform, is all about, just like Traced. And that is what we're going to dig into here today, is how you perform that incident response, what happens when you need to respond to an incident on the Android devices. So that same guide, this Computer Security Incident Handling Guide, provides this process for handling incidents, and it's very good, very effective, but I actually prefer the one provided by ISO 27735, which is a little bit simpler, which is why I prefer it. I always think simplicity is the key to these things and getting them right and making them simple and easy to understand. And the way that this goes is it says detect your threats, assess that threat or assess what it is and how many people it's affected, then respond to that. So perform some form of response, like eradicate the threat or lock down that machine that it's happened on, and wipe the machine perhaps after your forensic analysis maybe. Learn from it. So what could you do to stop yourself ever being affected by that again? How did it get in? What happened when it was in? How could we stop it at the different parts of the attack chain? And then plan. So plan for how you're gonna put new solutions in place, fix these things in the future. And I guess we're not going to be talking about learn and plan specifically. However, your plan phase would include doing something like setting up trace control within your environment and making sure you're protected from these mobile threats in the future. But right here, we're not going to set it up necessarily. We're just going to detect, assess, and respond to that threat. So that detection phase, how does this happen with Traced specifically? The Traced app will be installed on a device within your organization. And that device will detect something based on a specific set of conditions. So perhaps there's a man-in-the-middle attack on a network, or what we're going to be focusing on today, in fact, is going to be on Android devices specifically. We can detect a malicious app based on previously known malicious apps that it's seen before. And it uses deep learning to do this. So by doing this, it's not going to detect just those known apps. Instead, it's going to detect anything that looks similar to the known apps it's seen in the past. So it uses those parameters to not just detect, the signature-based detection that you'd get on traditional antivirus that is still used a lot in mobile devices today. Instead, it detects a whole plethora more just based on the similarities of the malware families. So then we're going to get into the assess phase. And the assess phase is going to be quite kind of the first thing that we jump into, because we've already got that detection sitting there in control, and we're going to assess the threat, assess how many people it affected, and then start hunting for other threats similar to it in our organization. So let's get straight into that rather than dwelling on a long, tedious slideshow any longer. If I can. Yeah, there we go. So here we have trace control, and specifically in trace control, we've got this Adobe Flash Player app that we've detected and it's been passed back up. The first thing that looks very odd about this is the name of the app. It's got this very random name that it's given itself, and this is a common technique used by malware to try and evade antivirus. Once again, that signature-based approach, which may be based on MD5 hash or SHA-256 hash, which will likely be changed by changing parameters like the name. Now there is something called fuzzy hashing, where this hash will be able to catch similar apps which have only got some minor changes based on a fuzzy hash. However, we'll be able to see that the file size in those apps starts to change a little bit based on padding or other information that's changed in the app in order to avoid fuzzy hashing. But on Android, we've got the joy of having this signing certificate, and the signing certificate is used by it's used when you develop your app in order to say, hey, I'm the signer and I'm the author. And for instance, we have a signing certificate here at Trace, and it's the same amongst all apps that we develop, although we only release one on Android and one on iOS right now. I'm sure that may change in the near or not too distant future. But this signing certificate quite often doesn't change throughout the variants that malware authors produce, because they're a little bit sloppy sometimes. And in fact, this particular signing certificate, I happen to know that this is the debug signing certificate on Android. So when you download Android Studio, this particular signing certificate is the default one that you will wrap your app with. So we could block this prematurely and just say that anything signed with the debug signing cert is just blocked in my organization, which may make it easier for me to stop a few threats coming through the door. But we'll get into that in a bit more detail further on in this assessment phase here. What we can also do in control is have a look at the permissions and see what it's requested here on the device. We've also got the intents as well. So starting off with the intents, a lot of people don't really know what these are, but what these are in very simple terms is the starting points for the app. So where is it going to launch, for instance? An intent is a way that it will launch. And we can see that it's going to launch if there's a send or a send to. So that means it's probably going to be something to do with sending messages, perhaps. And they've also got respond via message in here. But we've also got reboot. And reboot is a very, very common intent on Android apps. However, it does mean that when you finish your boot or your reboot or update, it's going to be likely to start. The app is likely to start, which means it gains a little bit of persistence. And you've got to wonder, what kind of apps need persistence? I know Trace needs persistence because it needs to be running at all times to detect these threats, but other apps perhaps need them for other nefarious purposes. If we look in the permissions as well here, we can see that it's got a few things which are unusual, like call phone, send SMS, but also receive and read SMS. Now, read SMS has been used in the past to steal two-factor authentication or multi-factor authentication, MFA, tokens. So just by looking at this alone, we can know that it may be having access to those MFA tokens that are getting sent down to the device. Now let's dig into this a little bit further. Let's get this MD5 hash and paste this into VirusTotal. And we can see that there are 30 people or 30 organizations which are currently detecting this app. So it's not just Trace that's detecting this particular one. Some of them are labeling it as Cerberus as well, and Trojan Banker. And I happen to know, from doing a little bit of research around Cerberus and analyzing the threat before, that actually Cerberus happens to be one of those apps which steals MFA tokens. So it takes those SMS messages that are coming in order to try and steal your banking password and the MFA as well. It also scrapes Google Authenticator often to steal the MFA tokens from there, and other authenticator apps, of course. So we've kind of assessed what this particular threat is, but how do we search to see how many devices it's affected? So let's take one of these hashes and MD5 or SHA-256 and paste it into my search box here. And actually we can see that this is now displaying 10 of 10 apps. So we've got 10 particular versions of this very specific app lurking within my estate. Now, what I can also do, let's go back to the app here, and let's grab this signing certificate hash, because we can search by signing cert hash here in Trace Control. And we'll be able to see anything else that's signed by that same signer. So it's quite interesting. There's 526 apps here that are high or medium risk and signed by that default debug signer here sitting within my estate. I've got this TechBigs Interflix. There's quite a few unusual apps here that perhaps you'd want to look into. Google Update, for instance, Google Service. I can imagine they're probably not, unless your organization is Google, it's unlikely that you're going to have that signing certificate used to wrap up your apps there. So quite a few that we could look into and further this threat hunt within my estate. So that signing certificate is so useful to be able to understand how badly you're affected by a specific strain of malware. Now what we're going to do is we're going to get into this respond phase here. And the way in which we can respond in Trace Control is by blocking the specific app. So let's take this signing cert and let's say this is Cerberus, and we can add this to the block apps list. And if I click create now my devices that have been signed by this signing certificate, my devices that have had any apps signed by this signing certificate will be warned that those specific apps are malicious and they can uninstall them. So this is the first stage of the response effort. We can also go into the Devices tab here, select a device, and actually revoke its sign-in sessions on any integrations that you've put in place, whether that's integration with Azure or other. So that's a quick whistle-stop tour to how you can threat hunt using Trace Control. If you want to try this for yourself, just head to trace.app. And you can get a 14-day free trial. But of course, get in touch with us as well, because we'd love to take you through how this can help you and your organization meeting those ISO 27735 standards for your mobile devices. Thank you very much for watching today, and I hope to hear from you soon.